This is another example on free fall motion. So there's an object that is projected upward with an initial velocity of 40 meters per second. First, we need to find how long in terms of time does it take for it to reach its maximum height. Part B, find that maximum height. And part C, find the time it takes for the object to come back to its starting point, or what we usually call the time of flight. So let's look at part A. Find the time it takes to reach the maximum height. So let's say that our object is like this, and then it has this vertical velocity of 40 meters per second. I'm going to draw the positive direction like that. So anything in the upward direction, moving upward direction, that's considered positive. The acceleration due to gravity is pointing downward, and it has a magnitude of minus g, and sometimes that's given as 9.8 meters per second squared. So as I told you earlier, this is something that you have to do at the very beginning of every problem. It is very important that you define your coordinate system, like what's the positive direction, what's the negative direction, because you are dealing with vectors. That's the main reason. So now let's try to find the maximum height. So what's happening here is that the velocity is in the upward direction. You can see that the acceleration is pointing down. The acceleration is actually not supporting the velocity. It's actually hindering its motion. So as a result, the velocity is going to decrease. It's going to slow down. And then at a certain point, it's going to become zero. Instantaneously, the velocity and the speed, it's going to become zero. And that corresponds to the maximum height the object reaches in this particular motion. So it's at this point that you find the maximum height. Okay, so I'll use a different color to represent that special point. So this is called the maximum height, which happens when v is equal to 0. Okay, so I'm going to break up this motion as a b, so that's the starting point. So that point is my b point, and then I'm going to look at the motion for the first part, motion from a to b. Motion from a to b. So then we have to use an equation to solve this. So let's assume that the starting time is t0, and over here let's say the time is t. So the objective is find the time, and this is the equation that I'm going to use. V equals v naught minus gt. Okay, so this comes about from this equation. V equals v naught plus at, where instead of a we have substituted minus g. So that's what we have over here. So then final velocity, we know that's 0, equals plus 40, that's the starting velocity in the upward direction, minus 9.8 multiplied by t. And from here we should be able to figure out what is that time. You'll see time is equal to 40 divided by 9.8, and that's going to yield 4.1 seconds as the answer. So that's up to 2 sig figs. So that's the time for the ball to move, for the object to move from point A to point B, where point B corresponds to the maximum height of the trajectory. That's how you do part A. Now part B is asking find the maximum height. So in order to do that, so part B, we need the maximum height. So if I redraw that sketch, we have the 40 meters per second object, that is its initial velocity, and it's going like this and then turning around, and this corresponds to the maximum height v equals 0. Let me call that y equals y max to represent that's the maximum y position, and then this is y equals y naught. In other words, that's your 0 coordinate if we consider that. So we need to find y max minus y naught, or simply y max. So I'm going to write down y minus y naught is equal to v naught t minus 1/2 gt squared. So this is one way of solving for the for this height. Okay, so y max, that's the value, the position at the highest point, minus y naught is the starting point, and I consider that as 0. So that's 0 equals v naught is 40 multiplied by t, which is 4.1, minus 1/2 9.8 times 4.1 squared. So this will yield us the position of the point at the very maximum point. That's what we are going to get. Y max, if you solve this, you are going to get 82 meters as the highest position. The coordinate, the y value of the highest position is 82 meters. And since it's in the positive direction, like you can keep it like 82, or even you can put like a plus 82. It does not matter because it's the same thing. Okay. Now this is method 1. So let me show you the other method. Method 1 to solve this. Now method 2 to solve this same problem is to use the other kinematic equation, which is the other one, that is v squared equals v naught squared minus 2g y minus y naught. So that's the other equation. We know v naught stands for this velocity at the highest point, that is 0. Velocity initially is 40, but we have to square that, minus 2 times 9.8 times y is the final coordinate, y position, and that is my y max, minus y naught is 0, and from here we can solve for y max. Y max would equal 40 squared over 2 times 9.8. Then again you are going to get the same value of 82 meters. That's in the positive direction, so we can write it like that. So the height, this is the position. Y max is a position. The height is the length from the reference level to that position. Part C of this problem is asking for the total time, that is from the start, that is from point A through point B, and the ball comes back to point A. So find the total time. So if I call this total time t, that is sometimes what we call the time of flight. Time of flight. So one way, again I'll show you two methods to figure this out. So let me call the first one like method 1, and we can use y minus y naught equals v naught t minus 1/2 gt squared. So this kinematic equation to get that time of flight. Now y is the final position, y naught is the initial position. You can see over here the object comes back to its original position. So y naught is equal to y in this particular case. So that means this quantity on the left hand side is 0 as a result, because the object, as I told you, it comes back to the original position. So what does that mean? The displacement of the object after traveling is 0. So this tells you the displacement of the object is 0. That's what it tells you. So then we have the left hand side is 40 multiplied by uppercase T, that is the time of flight we need to figure out, minus 1/2 times 9.8 uppercase T squared. Okay, so you can solve this expression. So then you are going to get T equals 0, because this is a quadratic equation, or you will see you are going to get T equals 8.2 seconds. So obviously T equals 0 corresponds to the original time, the initial time when the object is projected. That is T equals 0. Because at T equals 0, the particle is again at that initial position. And after a time of 8.2 seconds, the particle goes through this trajectory and comes back to the same position. So that's why you get these two time values. So we are ignoring this one because that's not what we are interested in, but this is the one that we are interested in. So that's your answer. This is method 1. Method 2 is we can look at the symmetry of this problem. So we can see that T in the upward direction, if you recall, that's 4.1 seconds. That is T upward. Similarly, when you're going in the downward direction, that is T downward, that has the same value, 4.1 seconds. So time of flight is equal to T upward plus T downward. And then you get 2 times 4.1 seconds, which is 8.2 seconds. So this is the other way of doing the same problem. Simply looking at the symmetry, we can conclude, since there's no air resistance, that's the main reason we ignore air resistance.